Examples, yesterday, the most confusing one was the last one. Guys, look with me at the third one. I just want to make sure, and we're going to do a couple examples today to make sure that we understand why the whys. Why the whys? Can anyone tell me why the whys? And I think, give me 1 second. And I think some of you might not have finished this example with me. So make sure you write it down. We were writing an integral that expresses that area. Why the whys? Josh.
Because if you use the x's, it doesn't touch the x-axis all the way, like the area that you're trying to find doesn't touch.
Two ways of thinking about it. One way is you can say, if I was thinking in terms of x, am I going down or am I going across? If I'm thinking in terms of x.
Down.
Yeah, look back at your forever card, it helps. In terms of x, am I going down or am I going across? Down, right? Up and down. If I was doing in terms of x, it would need to be the curve to the horizontal axis. Well, hey, this is normal integral, normal integral, normal integral, normal, right? So it was blue curve to the axis, right until x equaled what? 0. And then at x equals 0, now suddenly it's blue curve to the green curve. So if I did, okay, challenge. If I did want it in terms of x, how could we state it? If I did want it in terms of x, how could we state it? Let me ask one more question while you're pondering. If I just did blue minus green in terms of x, blue minus green, question, would it be this exact same area? Because it would go blue to green, blue to green, blue to green for the entire interval of x's that I put it, right? So I can't go blue to green the whole way either. It's blue to green until x equals 0, then suddenly it's not. So 0 to 2 wouldn't cut it in terms of x. Hold on, why was it 0? Well, we'll come back. How would we do it in terms of x? I'm going to put an or. I'm going to put an integral with a dx. Actually, I'm going to put two integrals with dx's. We're going to take it piece by piece. How would I do it in terms of x? Well, kiddos, for the first part of this interval, or for the first set of x values, blue and green, right? What would my x values be for blue and green? Starting at, what's this x? How would I know? Intersection point. Ooh, what did we find yesterday? Well, we found the y's. How do we find the x's? Right? So then, if I plug in, well, -1, oh, that's the y down here. Forget that one. Plug in 2. Oh, yeah, there we go. Plug in 2. So then 2 squared is 4. 2 minus 2, -2. X is equal to -2. And then we can already tell by the picture that's +2, but we could also plug in -1, -1 squared. It would be +1. Ooh, that's right, because it intersects down here. Well, yeah, of course, because y is squared and x is singular. This is a parabola, but the y is squared. It's a right-left one, and the y squared is negative, so it's a left one. That's technically the whole thing. We just can't see it all. Anyways, so I'm going to go from -2 to what?
2.
Well, I do want to go to 2, but question, if I'm going top-bottom, doesn't it change somewhere?
-2 to 0.
Yeah, -2 to 0.
Okay.
And then 0 to 2. All right, we got the bounds. Now what? Fill them. Fill what? Fill the integral with what? Top and bottom. Okay. Uh-oh. If I have dx, what do I need my functions in terms of? Stink. What are my functions in terms of right now?
Y.
Bummer. So to get it in terms of x, what do I have to do? Y equals plus or minus. This one's easy. Okay. Y equals -x. Ta-da! Yay, we have one. Question, plus or minus. Can I plug in two functions at once? Nope. They wouldn't be functions if they were both together. Oh yeah, that's right, because it fails the vertical line test. Question, what piece of my parabola am I talking about? Like a circle, the top piece or the bottom piece? top piece. So am I worried about the negative right now? So I'm going to use the positive top, square root of 2 minus x, minus bottom. Who's the bottom from negative 2 to 0? There we go. Top is the blue, but the positive root. And then bottom is the green, right? But from 0 to 2, what's the top? Blue. What's the bottom? From 0 to 2. The axis. And the axis, well, that's normal, but if you want to think about it, what is the axis? Oh, okay. What if it was like to y equals negative 10? Whatever, shift it down to negative 10 and then just say minus negative 10. That's why sometimes it's useful to think about what's the bottom, even though it is just the axis. So guys, would these both solve the same way? Yep. If you plug them both in your calculator, this one,
Yeah.
in your calculator, do you have to worry about putting in like y's if you don't want to? Your calculator is just solving the integral, so it doesn't matter whether they're x's or y's. Just solve them. Sure, you can use peas if you want. Okay, but, or green beans, but if you go ahead and plug in, just kidding.
Snap.
Just kidding. Both would solve the same way. Let's keep going. You guys. You've seen me do one with x's and y's. Can you do one with x's and y's? Can you figure out which way would be easier with x's or y's? And no matter what you do, whether you do the shortcut or whether you do visually, you're going to want intersections. Take a moment. If you want, you can think about it visually and get a graph. Wait, it's y squared. What does that mean? Oh, it's a parabola that's right or left. Just a hint. Whichever way you choose, you have to find the intersections. That's just a given. That's a must. But if you want to, you can try to draw the picture and see if it helps you. But if you're like, you know what, there's that absolute value thing, you don't even have to worry about a picture. See if you can do it without even drawing a picture. We'll give you a couple moments. Where's my office?
That's the square root. Excuse me, pardon me.
Sorry. This thing. What does mean over here?
Oh, with respect to. With respect to. AKA dx dy. With respect to. Using x's with respect to using y's. We all understand the question now. Alright, well, let me try. I'm going to do the mathematical shortcut way.
Yes.
And then I'll come back and do the visual way. You guys just do whatever way you think that you get. You go. Focus. As the whole kids run. Anyway, you try. Try to focus. Guys, why am I not modeling us actually solving these integrals? What do I assume that we can do? Okay, just double checking. Not saying that you can never use your calculator, but just a hint. The AP guys would probably not have this on the calculator section unless the intersections were decimals. If the intersections were decimals, or are decimals, definitely you can use your calculator for everything. For graphing, for finding the intersections, for solving the integral. But if they're not decimals, they could expect you to do it by hand.
Are those absolute values?
Yep. Because shortcut, I just picked one and subtracted and said, I don't know which one's which, so I'm just going to subtract and then say, yay, go. And if it's negative, I'll make it positive, and if it's positive, I'll stay the same. Why did I choose dy?
Because it says with respect to.
Well, yeah, but I chose which side, didn't I? Couldn't I have chosen the other side?
Because you put it in like that.
I put it in terms of y. Yes, I put it as functions of y first. Why? Why is it easier to make it functions of y than functions of x? Y is squared, and so parsa, what's going to happen if I try to get y by itself to get it in terms of x? Plus or minus stink. Now instead of having two functions, I have three. Things just got a bit trickier. But if I only have two functions, or if I only have two expressions, if I only have two intersections, shortcut says, cool dealio, they can't cross places, so I'll just do one minus the other. I don't know which one's which as to which one's bigger or smaller. But whatever way I subtract, the number will be the same. I just need to make sure it's positive at the end. Right? Visually. How many of you guys tried to go to visually first? No one? Really?
There's a shortcut.
Well, doesn't mean you all got it. Anyway, if I have y squared equals 4x, if I was to do with respect to x, I'd have to say, hold on, this is not the example I'm remembering from this morning. No, it's not. That's the example I was remembering from this morning. X is equal to, y is equal to plus or minus square root of 4x. Over here I have y already by itself, which is why some of you might have thought dx, but that's not a good idea. And here's why, because if I was to graph, long story short, I would pretty much have it centered at 0, 0. How do I know? Well, if I tried to complete the square, it's y minus 0, x minus 0. I'm thinking back to conic sections from last year. Anyway, there he is. My line would be an intercept of -4, right? So like down here somewhere. And then I go up 2 over 1, up 2 over 1, sure. So I have, what are the two intersections they're talking about?
Find it.
Y is -2 and y is 4. So I have intersection 1, I have intersection 2. Do you guys see how y -2 and y 4 splits this nicely? Green is always on the right, blue is always on the left. Sweet, let's just go side to side. That's why I chose in terms of y, but mathematically you could also see it here. This is a lot better than that. If I was to do in terms of x, we see it, right? Do we see it? Do you guys see it? We see it. But how could we express it if we were doing in terms of x with top bottom? First of all, I need my x's. Hold on. If y is -2, plug in -2, -4, -8. No, that's not right. Hold on. Where am I plugging this into? Let's put it here. -2 would be +4. 4 divided by 4. X would be 1. Okay. X is 1. So I have 1, -2. And then if I plug in 4, 4 squared 16, 16 divided by 4 is 4, so 1, 2, 3, 4. Guys, even though x says, hey, 1 to 4, is it really 1 to 4?
No.
Where does it start? Ah, stink. So therefore, if I was to do it with respect to x, visually with y, guys, did I actually put it in the right order? Did I do the bigger one minus the smaller one? Did I do the bigger one? Did I get it right? Which one's more right? The linear one or the quadratic one? The linear one. So if I was doing it visually, these would have been switched. It would have been perfect. I wouldn't have had to switch the sign. I actually purposely chose the wrong one to say even if you did it the wrong way, absolute value will fix it. With respect to x, I would have to split up my integral from 0 to 1 and from 1 to 4. Because if you look, top bottom here, blue and green. Green we already know is y equals 2x minus 4, right? Blue, would it be the positive or the negative square root? What am I talking about up here? Positive. So I have the positive root 4x, I have the negative root 4x, and I have the 2x minus 4. Okay. So on top would be the positive root 4x, on bottom would be the 2x minus 4. Ooh, I switched it. Where should he be? Why? Blue, green, blue, green, blue, green, blue, green. Sorry, I'm saying it backwards. Blue, green from 1 to 4, right? But what about 1 to 0? What's on top?
Blue.
And what's on bottom? How is that possible? Because there's two different functions. So on top would be positive root, and on bottom would be negative root. So I would have positive root minus negative root, which would end up being the double root, 4x, but either way. Anyway, you have to do one big addition. Anyway, long story short, guys, sometimes is it easier to do it in terms of y?
Sometimes.
Yes, and sometimes is it easier to do it in terms of, to find the area between, where's one that's easy to do in terms of x? That one, right? Because look, top, bottom, easy cheesy. Top, him, bottom, him, got it. Sometimes easier to do in terms of x, sometimes easier to find areas in terms of y. That was the point. Is it always possible with both? Yes, but it can be quite complicated. Dai, go ahead.
For the second one, is it square root for x or square root for nx?
Okay. Hey guys, did anybody see this? It's actually, it was back in chapter 6b. I think the questions were saying like find the area, you're supposed to use an integral, and they were giving you like extra things like y equals 0. And you're like, what? It's because it's technically an area between problem. We talked yesterday, area between is always supposed to be what? Positive. Let me think of how they worded it. Someone asked me a question about this yesterday. Lee, was it yours? From chapter 6b? I don't remember. But you guys have kind of seen this before, but maybe didn't realize all of what it was saying. If you were to graph this, well, let's try not graphing. Kiddos, what if you were just to do the mathematical shortcut? What would you think? In terms of x or y? Which one? Y. Y x's. Yeah, it's right there. It's ready for me, right? Let's just do dx. And some of you guys might be switching what I mean by in terms of x or y. What I mean is like dx or dy. So you should say dx, please. What if you said dy? What would you have to get by itself?
X.
No? Okay, no. So then if I wanted to do the shortcut, you guys tell me, what would you do and would it work? I'll tell you. Integral. 0 to 2, bottom to top. Who's the other one? Got it, done. It's that easy. Right? Not bad. Visually, real quick. Go ahead, Russell. Oh, because if we're doing area between, there must be two different, and that's why they gave me. I have two different.
Oh.
Because otherwise, well, let me show you. This is a funny one. It's one of those ones. I think this is the point 2, 0. This is the point 0, 0. If we were to take the derivative, that would be 3x squared minus 4. So then the minimum, maximum, 3x squared minus 4 equals 0. plus 4 divided by 3 plus or minus square root. That's not a nice number. Whatever. I have other points in between. Okay, so I have 0 and I have 2. What are they talking about? If they didn't tell you this, could you think like, hey, I'm going crazy, right? That doesn't work. Why did they tell you y equals 0?
It's a bound.
It's a bound. It's a boundary. So what boundaries do I have? Well, I have the curve. I have y equals 0. And I have x equals, cut it at 0, cut it at 2. What piece of the graph is cut at 0 and 2 and bounded by? This one right here. You guys see it? Why did I do absolute value?
Because it's negative.
If you do this minus this, I did it backwards, it would have been a negative. I'm trying to find area between. I need to make sure it's positive. This would be my shortcut visually, technically. If you had looked at it and said, who's top, who's bottom? Which one's more positive? Which one's less positive? You would have done 0 to 2. What's on top? 0. What's on bottom? Function. And you wouldn't have needed absolute value, but whatever. Do we really need to find the picture? No. Sweet. How about this one? dy or dx? I totally agree with dx. Why? But they gave it to you in terms of, wait, wouldn't you have to get x by itself? And it'd be a plus or minus root y? Let's not do that. Doesn't sound very fun. So, doing it in terms of dx. You guys all shortcutting it with me now? If we're shortcutting, make sure you have absolute value. Hold on, some of you aren't. Didn't we have test corrections due yesterday? How many of you guys messed up absolute values somewhere? Lots of you. So, hands down. I won't even look. I already know who you are, but I forgot. If there are absolute value bars on the outside, do I still solve the integral inside of them like normal?
Yeah.
Yes, and I do not make anything positive until I have my final answer of the integral, right?
Yeah.
Don't go making like pluses, minuses, and minuses, pluses, and this, that, and the other until you've solved it. Solve it, make it positive if it needs to be. Okay? What are my bounds? They didn't give them to me. Intersection, no big deal, right? So therefore I can go ahead and set x squared equal to what? What'd I do? Right? Just get 2. Y and y. Get it equal, and say y's are the same. Ta-da, done. So then I have x squared minus x minus 2 equals 0. Therefore my intersections are, did you guys already find them? Sweet, what are my bounds? Which one goes first? I don't care. Which one do you want?
X squared.
Sure. Done. Huh? Did I do something wrong? Is that okay? Okay. If you were to, okay, not done because I don't have an answer, you'd have to keep going. But if I were to graph it, what would it look like? Parabola. Line. Area. Could I have done it in terms of y? Yes, but I would have had a funky like green to green and then green to blue and it just would have been horrible. So let's just do it in terms of x, it's easier. Moving on. What about
Box.
dx? That's real. dx?
No.
Why not dx?
Because the way that you measure it is from the y line, so it's more accurate.
If I wanted dx, what would I have to get by itself to have a function of x's? Who wants to get y by itself? Go.
No.
It's not possible. All right, so then what do? We say dy instead, right? Ta-da! Got it. You guys, do the shortcut. Let's see if we can actually do it. But there's a cubic. It's okay. Be amazing. Go.
Which particle?
We've been doing cubic functions since, what, Algebra 2? You don't like them, but we've been factoring them. Synthetic division, factor remainder, eyeballing it and see if you can just see it. And if it was a decimal, you'd use your calculator. Carson.
For homework, are we allowed to use our calculators?
No.
Since you're just like not doing that. Or
You're just to be able to do.
In class, we have to go over the hard things because the foundational things we try to learn.
Okay.
Why is there an 8 on my desk? So, in homework, if the intersection,
Eight stands.
if the intersection is a decimal, you're allowed to do everything with your calculator. If the intersection is a whole number, you can check with your calculator, but you have to do it by hand. Do you guys hear that?
No.
If the intersection is a decimal, you can use your calculator for the whole thing, including the integral. If the intersection is a whole number, you gotta do it by hand, but you can check with your calculator. Unless they say something like use your graphing utility, then of course you can use it. What's the hard part on this one? Didn't we figure out it was already like in terms of y? No big deal. Take one, subtract the other one. I don't care which one. Except, what don't we know?
Where's the balance?
Oh, that's right, the bounds. How do we find the bounds?
Equal to each other. Intersection.
Oh, aren't they nice? They already have it solved for x, so I can just go ahead and, well, I guess I must need to move things, huh? It'll be so much nicer as soon as I,
Like that.
lucky ducks. What's true? Yeah, get that y out of there, right? Okay. So I have y squared minus 5y. Now, if there wasn't a y, and sometimes, like on the AP, there might not be. There might be like a plus 7. Oh, stink. Keep going. Now what? Parsa got, or not Parsa. Russell, you got it. Parsa was talking though. Y equals. How is usually true. Okay, so.
Oh, burn.
That was a little bit hard. What? Guys, why do I have to say? What's wrong? Okay, hold on. Actually, I'm going to bring it right back. But why can I not say that that is my final answer? There we go. There are how many bounds?
3.
If there are 3 bounds, could they have switched places somewhere? And if they switch places, and if I just say from 0 to 4 and I stop, I very well could say 0 to 4 the right way. It's a positive. 0 to 4 the wrong way. It's a negative. Ah, stink. Now it's a smaller number when I should have added the absolute value of each. So, I'll show you a visual in just 1 second. I can do 0 to 1. But what else do I have to do?
1 to 4.
Just like, oh, that didn't work. You guys going from 1 to 4? You should be going from 1 to 4. Go from 1 to 4. Struggle. Struggle. Where are you? Come here. There you are. Okay, all better. You guys got it?
Almost.
What would be next? And you don't really have to stress about who's who or where's where, and just say whatever, take one, subtract the other one. My ones who do badly with negatives, make sure you group things, or else you're going to have one be and one not be, and then you're in trouble. To be or it came back. Okay. Area between. Ta-da! You're not solving it, guys. Seriously, okay, you're fine. Just be careful. Positives, negatives, numbers, plugging in, multiplying, all that stuff. So, what if you did want to visualize this?
Then you'd be crazy.
What's wrong? If I plug it into my graphing calculator, I'll be plugging in y equals x cubed minus 4x squared y, because that's all I can do. So what's the relationship between x equals y cubed, and y equals x cubed, What happens when I switch x and y's?
Reflected.
They're inverses, and they're reflected across what?
The white.
So I could really just graph it and then reflect it, right? No big deal?
Big deal.
Is there another way to do it? It's just a warning, these are kind of messy. Is there another way of doing it besides graphing and reflecting?
Yes.
You could go, that wasn't what I wanted to do, to parametric mode. Why? Why can I do that?
Because T's.
I get to define both, so I can say whatever, y is my variable now, x, here you are. And y is my variable now, x, here you go, right? Wouldn't these match those? Now the problem in par mode is T-min, T-max, T-step. Remember those?
No.
But you could get a pretty good, you could get a pretty good approximation as to what the areas would be. Yeah, he's not very, sorry, he's little. But here's the problem, kiddos. If we were to go to par mode, remember I told you, kiddos in the back, shush. Thank you. Remember how I told you sometimes the AP guys will give you ones where the intersections are decimals?
Yep.
Can you do intersections in par mode?
No.
Yes.
You guys looked? Can you do like mins and maxes and all the cool second calc, second trace?
I'm gonna say no.
Yes.
Well, in par mode you can get a really good picture. Well, you can get better than that. I just didn't work too hard on it. But if I was to go to mode, par mode, right? That's not what I wanted. Par mode. There we go. And then I was to graph. We have all the x1s, y1s, et cetera, with t's. Do I have all the cool intersect and max and min and
Yeah. DY/dx, DY/dx.
I have derivatives, but I sure don't have intersections. So question, could parametric mode get you a good, accurate picture of what it looks like? Yes, with some work, and the window might be a little funky. But could it get you intersections if they were, say, decimals? No. So what would you have to do no matter what? Graph it in, if they were decimals, you wouldn't be able to solve by hand. You would need to graph it in function mode, but would the picture be exactly accurate? No. It would be this, but like that. You'd have to think about it like that. But question, if you flip it and you find intersections, then question. Intersections are points, right? And points are x's, y's?
Yeah.
But if you switch the x's, y's, your x's, y's could be seen as y-x's. Ta-da! That's how you could do it. Anyway, we won't talk more about that until we get to nasty AP questions. I don't think anyone's in your homework are quite that bad. We are going to talk about an AP FRQ tomorrow. Maybe. I still have the last week right before spring break when everyone's going everywhere except for class, so we'll see what we have to do. All right, well, kids, pack up. You have, oh my goodness, 52 seconds. Enjoy them.
You should have saved that big just for me.
I do have a pie can. No, not egg bake. That would be fine.
No, but I don't want you to share it with other people.
Slopefield, yes. You can turn this in. Just give it to me. Some cultures.
너는 왜 이렇게 또 남의 걸
That's weird. Guys, happy Thursday. Good job finishing. 3, 1, 2. Bye, guys. Sorry.
Yeah.
Alpha, I do